wide.
At
That's
some
why it's
great
wide and long.
high rate of speed by those autorhythmic cells in the atria.
Do those pathways just take it to the AV?
Those
That's
pathways
all
are
they do?
designed primarily to get it to the AV node and to initiate signals along the way that all go cell to cell. But the transmission is still predominantly cell to cell. And if we're talking about any sort of distance and time, we're talking micro milliseconds.
So it's just uniformity then?
Yeah.
Basically what the pathways do.
Yes.
Travel from the SA to the AV and create uniformity across the entire atrium.
Yes, it's a way to initiate atrial depolarization simultaneous to AV depolarization, so the AV can start its delay while the atria is doing its job.
Okay.
But everything in the atria goes cell to cell.
You'll have a normal-
Atrial pathways are not Purkinje fibers.
So you'll have a normal P wave.
So you have
And
basically
and-
well, normal,
Okay, you'll have a P wave.
you have a P wave. There you go.
If it's a pacemaker site, yeah.
If we have a pacemaker site.
Yeah.
And yes, there might be some size difference in that P wave based on where it's starting from, that's true. But we're talking about a very, very small change in time, not elongating. It's not gonna be you're not gonna see a change in that P wave like you see in the QRS complex.
Okay.
So essentially, with the original question, we're gonna see two rhythms on top of each other. Because they're two different hearts. One's either gonna be an atrial ectopic pacemaker or AFib, and then one's gonna be either a ventricular VTAC or ventricular rhythm or VFib. And they're gonna be laid on top of each other.
Yes, you could have any of those possibilities. James?
I don't know. We've already walked over it.
Okay? We good?
If you had that ectopic single ventricular pacemaker and it was firing, would you even see a P wave then?
So now we're at the same question that Annalise brought up, where she contradicted herself. She was dead right in one aspect, and a little incorrect on the other, and it gets to the question that you're asking also. So would you see, if you have two pacemaking sites, one in the atria and one in the ventricles, would you or would you not actually see the P wave, and why or why not?
I guess you would see it if there was a
Timing.
segment to, if the rates were different enough and there was a segment for repolarization,
of
Okay,
the
so what were the parameters that I gave you?
there were no
autorhythmic.
autorhythmic
Okay,
cells.
so that right there gives you enough information. Chandler, did you have something to
I
say?
was gonna say that the atrial cells have a higher, not excitability,
Intrinsic rate?
what was that?
Intrinsic rate?
Higher intrinsic, they're more, excitable's the wrong word, it's unstable, correct, they're more unstable with a higher intrinsic firing rate.
So therefore,
You'll have a set, you'll have a set, if you have an ectopic site, you'll have a set rhythm at that intrinsic rate, which atria is 60 to 80.
great,
In conjunction with that, you'll have an intrinsic firing rate of ventricles, which is 20 to 40,
great.
of which you will see both of those appear on the EKG. However, sometimes you might not see one of the, or might not see the P wave because it's buried inside the QRS segment because it overpowers the P wave, because they just happen to fall on top of each other.
Okay, does that make sense, what he just said?
Yep.
Right? So you will see P waves in that set of circumstances because there is a given period of time where the QRS complex is not happening. And yet there will still be atrial activity because the atria happen faster. Does that make sense? In other words, you'll have this in the atria, right? You'll have this in the ventricles. Right? Because it's slower. And when we superimpose those on top of each other, maybe this one is hidden because it's happening at the same time as the QRS, but what's happening at the same time as this
You
one?
see it, a segment.
You see it.
And this one is, you might have partial hidden, partial hiding, partial not hiding, and this one is
Seen,
seen, and this one is,
seen.
right? So that's completely dependent on the the overlapping statistics of where those happen to fall.
And same thing with AFib or refib, you see underlying AFib.
And
refib.
so
Yeah.
we would have called this, if you would have seen this conglomerate put together, you would have called it what up till now in your EKG life?
Third
You would have called this a third degree heart block, and you would have been correct, right? We're not going to get into it right now, but there's a rhythm that we call atrioventricular disassociation. That's where there's a disassociation of the atria and the ventricles and the way that they're firing. Third degree heart block is a type of AV disassociation. It is not the only kind of AV disassociation. I'm not going to make you know that just yet. My point there being, there are things that disassociate, change the relationship between the atria and the ventricles. This is an example of that. That make sense? Good?
What is the intrinsic rate of contractile cells?
What is the intrinsic rate of our contractile cells in the ventricles?
30 to 40?
Or are they the same?
What is it? 20 to 40.
40 to 40.
What is the intrinsic firing rate in the atria?
60 to 80.
Give or take 60 to 80.
So it's the same as for the arrhythmic? That's what they're.
Well, there are no arrhythmic cells involved down here. And up here, yeah, the atrial pathways and the atrial contractile cells are, give or take, approximately the same.
Okay.
They're a little off, but
But the numbers.
Not enough to be a
match up
major.
Pretty close, okay.
we good with that so far? Yes.
You had mentioned VTAC.
I didn't mention VTAC. You guys all had said the word VTAC.
It would
That
look
word
like
has not come out of my
VTAC
mouth yet
I
today.
thought you said it would look like VTAC.
No,
You
I said
did.
that.
I did.
Or
Oh.
he did. Someone over there
Okay,
did.
You said the-
no, it confused me.
The word VTAC has not only not come out of my mouth yet today until just now, but I've been doing everything I can to get you away from thinking about it.
Great.
You're welcome.
You're welcome.
Thanks for confusing me.
Right? Ventricular tachycardia notes a very, very specific thing, and that is a rate that is
Fast. And
fast. And I've said
Right.
there's
That's,
no autorhythmic involvement, so
it can't be
how
fast.
can we possibly have a tachycardia?
Okay.
Okay, right?
Noah.
I just said it would look like
But you see the habit that we're in, because you're not the only one that said it, by the way. Your counterpart straight in front of you said it a couple times. Right? But that's a habit that we have.
you go.
The habit that we have is to go back to things that we're familiar with. And I'm really sorry about this, but some of the things that we're familiar with were wrong to begin with, or were not 100% accurate to start off with, and now we have to correct it. You walking into life thinking that this is what an EKG looks like all the time, and that's normal, that was wrong, right? You didn't get the whole picture. You weren't told that that came from one camera angle, and you're about to learn 15 other camera angles, that kind of thing.
Sorry, can you explain to me when you drew the ventricles down there, the S is super wide, and there is no T wave. Why is that?
Well, number one, who said that I didn't drop a T wave? And that T wave's not inverted?
I don't see it.
Who
What?
says that
inverted,
that's not
but-
the T
Is
wave?
that? Oh.
But
I'm just saying, who says it's not?
if the algorithmic cells are out, then the T wave's gonna look different too.
Right, so as you start to widen out your QRS and the depolarization of the QRS, it takes longer for that depolarization to happen, right? But this
Yeah.
cell over here is done depolarizing. So what's it gonna do at some point in
It's
time?
gonna repolarize.
That's right, so
Okay.
when you elongate your depolarization, you also make it closer to when the repolarization is going to begin.
Okay, and then
So
it doesn't go
sometimes-
out to in. It
Sometimes
goes.
your ST segment is no longer a long baseline segment,
Okay. All right.
right? Because your polarization started, your repolarization is gonna start at approximately the same time. But it might take longer for the depolarization to get through all the hearts, through all those heart cells, and so that'll elongate, but yet the repolarization is still gonna start at approximately the same time. So we get a meshing sometimes of the QRS and the T wave.
Okay.
They start to come together a little bit. Make sense?
Yep.
Questions on that? Yeah? Get up and stretch for a second.